Welcome to part 2 of Leetcode a Day Keeps the Dentist Away, TypeScript edition. We're going to be solving Leetcode questions using TypeScript. And now, as always, I'll be showing you guys multiple solutions to the same problem. And this one is add two numbers. If this is your first time on this channel, I do these Leetcode type of questions time to time. I'm only on the second one. It is my goal to get through all of these. I don't know if that's possible, but we'll try, especially if you guys like this content by clicking like and subscribing to my channel. That will help me tons. But I'm going to be going through these, and my goal is to make the most in-depth tutorial for these in YouTube. Quick interjection here. If this is your first time attempting a singly linked list question, I do have a very comprehensive deep dive into singly linked lists. This is my data structures and algorithm series in JavaScript and TypeScript. So please check that out if you haven't done so already. So let's read this question, and then I'll have you guys pause the video, try it on your own, and then come back to me, and I will show you the multiple solutions that I have come up with. Add two numbers. You are given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order, and each of their nodes contain a single digit. Add the two numbers and return the sum as a linked list. You may assume the two numbers do not contain any leading zero except the number 0 itself. So there was a lot of nuggets in there. Let's look at the example first. 243, 564, that will somehow give us 708. And let's remember what they have said. So the digits are stored in reverse order. So this 243 is going to be 342. And this 564 linked list is going to be 465. So what is 342 plus 465? That ends up becoming 807. And if you reverse 807, that will give you 708. So that should give you the linked list of 708. There's a couple other things to keep in mind is we are given two non-empty linked lists, meaning this L1 and our L2 will never be null. So I don't know why they typed it like here. Also, they are stored in reverse order, as we said. These are representing two non-negative integers. They will never be negative. And the nodes all contain a single digit, meaning we're never going to have something like 12 here or like -5 here or -24, anything like that. They're all single digits. Another thing that helps us out is you may assume the two numbers do not contain any leading zero except the number 0 itself, meaning we're not going to have extra zeros here to just pad the number. But that's essentially the same thing as 342, right? So that is this first question. Now, please pause the video, try this on your own, and come back to this to look at my solutions. All right, so the first way I'm going to solve this is we are going to make a function first that gets a list node like this and gets a list node like this and produces the correct number out of them. So this function is going to take this linked list or whatever, and give us 342, meaning it's going to give us the digits in reverse, and it's going to give us from here 465. So our first objective is to make a function that gives us the correct number in the number type for the two linked lists that we have. And then we're going to add these together. And then spit out the digits back in the reverse order as a linked list. So that's our objective. Let us go to our editor now. I have a code sandbox open here. Let me just zoom in here a little bit. Copy this. I've already copied the list node class here so that the TypeScript won't complain to us whenever we define it like this. And a couple important things to keep in mind. They told us that we are given two non-empty linked lists, meaning the way that they typed it is not actually correct because they're saying that L1 is either list node or null, and L2 is either list node or null. That's not correct. They should actually only be a list node. They can never be null. And because of that, because we're always going to have something for L1 and L2, that means we could always add something, and our output should never be null either. So let's get that out of here too. Now we have the correct type, and as I have said, our first goal is to make a function that takes in a linked list and spits out the number in the correct order. So I'm just going to define that as a function out here. So what should we call this? We will say get number from list. And this will take a list as an argument, which is a list node. And it will spit back out to us a number, like so. And this function, as I said, we're going to end up calling it for both L1 and L2. So what can we do to get this singly linked list as a number? All right, so in the beginning, let's not worry about the fact that these are in the reverse order. Let's just worry about putting these into, making this into a 243. Now, I got a question for you guys. Is it easier to make this 243 as a number or as a string? To make it a number, how do you get the numbers 2 and number 4 and make them 24? It's easier to get the string 2, string 4, and then concatenate them together to get the string 24, right? So that's what we're going to do here. So let us do this. Let number in reverse order. I'm just going to be explicit that this is in reverse order so that we remember to put it in the proper order afterwards. And this is going to be a string type, and we will instantiate it as an empty string. Because we're already instantiating as an empty string here, we don't need this typing. So we'll just let TypeScript infer it. And then we are going to use the runner method to run through this linked list and grab each value until the runner is at null. So let's define the runner. Let runner be the list. It starts from the beginning of the list. And we are going to do a while loop. So while runner exists, what do we want to do while the runner exists? We want to append to this number in reverse order string the value that the runner contains in the string format. So the way we are going to do that is number in reverse, if I could spell correctly, reverse order. We are going to add to that the runner.val, which is a digit, and we just want to string this to make sure that it stays as a string. And then after we have added that value, the current node is no longer of use to us, so we're just going to set runner equals runner.next. He's going to keep on going until he gets to the end. And right now, TypeScript is complaining to us because runner.next could also become null, right? Because for this 3 as an example, his next is null. So we typed the runner incorrectly. Right now, runner thinks his type is only a list node because that's what we pass as a list. But the type of runner can be either a list node or null, because at the end, it's going to become null. The TypeScript is no longer complaining to us. And now, we should have had the correct number in reverse order as a string. So now we want to make this into the proper order. And the way that I'm going to do that is I'm feeling a little bit lazy, so I'm going to be using a bunch of JavaScript methods that it provides us. So one easy method that I know on how to reverse things is an array. An array has a method called reverse that reverses the array. So I'm just going to convert the number in reverse order into an array. I'm going to store the result of whatever I'm going to do as the output. So this should give us the final number. So first, we are going to get the number in reverse order. We are going to make it into an array. The easiest way to make a string into an array is just by splitting it at every single character. That will give us 2, 4, 3 as an array. And then now that it is an array, we could just reverse it like so. Now it'll give us 3, 4, 2. And after we have reversed it, our usefulness of arrays are done. So we're going to join it back to a string. So now it becomes 342. And we just want to typecast this as number. And this is going to be our output. I forgot a parenthesis here. So, and we want to return this output, right? So we could either put a return output here or just erase this and return it straight away from here. Like so. So here is our get number from list. Let's think about the time complexity of this. So let's take a look. We are running through each of the list, each of the nodes in the list. That's O to the N operation. We also are doing this split, a reverse, and join. I don't really know the O to the N for reverse, but I believe it's O to the N. So this is something like O to the 2n operation. One way we could speed this up is not doing this whole reverse thing. And when we formulate the string, we add it in the proper order. So let me do a couple refactoring now to this. Remember what we were doing here. We were adding each value of the node to the end of our previous string, right? Instead of doing that, why don't we just add it to the front of the string every single time? So way that I am going to do that is I'm gonna refactor this and I'm gonna call this just number string. Then get this number string. I know this is incorrect right now, but let me just do the refactor first. We don't need to do this split reverse join crap again. So we are just gonna call this return the typecast of number string. And if we fix this, this should work. So instead of appending the value to the end of the string like this, what we are gonna do instead is we are gonna set the number string, get the value first, put that in the beginning, and then add the rest of the number string, like so. And what that would do is first we have to, let me get my pen out. So let me just show you guys what is going on here with this example. We first start out as an empty string. Number string is an empty string. We run through it. We first start with 2. So the empty string now becomes 2, like this. And then we go to the next node, which is 4. Our number string still stays as 2, but we are appending to that in the beginning the next value, which is 4. Like so. So that becomes what? 42. And then to our 42, at the end, once we are at 3, we are adding 3 to that to the beginning, which gives us the string 342. So that's essentially what we are doing here. This is a bit more performant than the other solution because we don't need to do the whole reverse split join stuff. Instead, this is a strictly O to the n operation. And now, just for fun, I'm going to show you guys one more solution on how to do this that involves a little bit of math. I'm not going to stick with this solution for reasons I will explain later, but I just wanted to show you guys. Notice what we're doing here. We are getting our number string as a string and then typecasting as a number. So there is a way to do this without doing the typecast, where our output stays as a number and we just return that. So because I'm not going to use it, I'm just going to copy this code here, bring it down here. And what I'm going to do is I'm going to say let output, let's let the output start out as 0. And let's just get, actually, let's just keep this. And we don't need to typecast it anymore. We're just going to return the output. So what we are going to do is this. Let me just write out the solution first, and then I'll explain what's going on first. After, I mean. So I'm going to have another variable here called index. And I'm going to start that out as an index, as 0. And that will pretty much be the index of each of these elements. Imagining this list node as linked list as an array. So what I'm going to do here, we're still going to be adding the whatever value that we get at the beginning, kind of like this previous solution, and adding that to the previous number, except this time it's the output, right? And this should also be the output. Instead of doing this string addition, we are going to do addition by actual numbers. And the way that I'm going to do that is this. We are going to get the runner.value, which is a number, times math.power of 10 to the index power. And then we're going to add that to the output. That will somehow give us this solution. Runner is equal to runner.next. I also want to increment our index. So why the heck does math.power of doing this work? Let me guys show you what's going on. So at the very beginning, our runner.value is 2, right? So we have 2 times 10 to the, what's our index right now, is 0 power, plus the output. Output started out as 0, as you guys can see here. What's anything to the 0 power? That's 1. So this gives us 2 times 1 plus 0, which is 2. And then we go to our next node, which is 4. So we have 4 runner value times 10 to the times 10 to the first power plus our previous output, which was 2. What's 10 to the 1 power? That is just 10. 10 times 4 is 40. And that gives us 42. And notice what is happening, right? We are getting the number. The next number is 3 times 10 to the 2 plus our previous number, which is 42. 3 times 10 to the 2 is 100. So 100 times 3 is 300. 300 plus 42 is 342. And that is the number that we want. So that's why this works. However, I'm not going to stick with this solution, and I will explain. That will be more clear later. So let's just erase this neat solution that we have here and stick with this solution for now, where we are just adding it to the beginning as a string and then returning the number form of it later. So we have beaten this get number from list function to death. Let's get to the actual problem of adding the two numbers, the actual main meat of the problem. And we are just going to call this get number from list twice. So we're going to say const number1, n1 is equal to get number from list of L1, and const n2 is get number from list of L2. So that will give us the two numbers. And what do we want to do with the two numbers? We want to add them together. So const sum is n1 plus n2. All right, so this sum now should be, for this example, it should be 807 because that's the number of adding 342 and 465. So how do we get from 807 to become the linked list that is 708? So how can we do this? So first, what we want to do is somehow iterate through each of the digits on the sum and form a linked list for each one. And the way that I am going to do that is, let's just pretend that we have made this iterable. And there's actually a very easy way to do that. Just make it back to a string, because strings are iterable. So once we have made this to a string, we're going to iterate through each of the digits, specifically 8, 0, and then 7. And this is what we're going to do. Once we get to the first digit, we will create a list node that points to nothing. We're going to go to the next digit and then create a list node that points to the list node that we have created previously, like so. And we're just going to continue this process until we get 7 that leads to 0 that leads to 8. So let's go to our editor now and try to implement that. So as I've said, we're going to first make it into a string. Const sum string is equal to sum to string, or to be short, why don't we just get this addition here and just to string it right away. That way we don't even need a sum string. All right, so now let's iterate through every single digit on the sum. So we will do for let I is 0, I is less than sum.length. This is a typical for loop. And let's just grab the digit that we want right away, that we don't have to deal with anymore. So const digit is going to be the sum at the current index. And now, as I've said before, we have to make a list node with our first digit. So our first digit here is 7. And the way that I'm sorry, it should be 8, because the number that we have for this sum is 807, right? And we want to return the result of all of this at the end. So how about we instantiate that in the variable here? So we'll say let output, which is going to be a list node, is not going to be null, but I'm going to type it as null for now because we're going to have it started out as null. Now, because we're always going to go with this for loop and we're going to put something here, it's not going to be null any longer. But for now, because we want to initially be null, we'll just set it as null. And this is what we'll do. Let output be equal to a new list node. We're going to create a new list node. What is the first argument of list node? It is the value. and the second argument is the next. So the value is very easy. It's just gonna be the digit, except the digit right now is a string. So if we just leave it like this, TypeScript is gonna error out. So instead, we will just typecast it like so. And what should our next be? Our first digit, which was an 8, should have a next of nothing. But once we go to the next digit, its next should be the previous output, right? So why don't we just put output here? Like so. So what will happen is we create 8 that has a next to null, because it starts out as null. Then we create 0 that has a next of the previous one, which was the linked list with 8. Then we create 7 that has a next to 0. And this should work. So at the end, we could return output. Now TypeScript is going to complain to us because we have typed the output as list node or null. We only did this because we want to have it started out as null, but it becomes a list node at the end. And we know we're always going to go through this for loop at least once. So we could just appease TypeScript right now by saying return output as list node. So this should give us the correct answer. Let us copy this, both functions, get number from list and the add to numbers. Just make sure you don't copy this class list node. Paste it here. And if you run the code, let me just zoom in here. If you run the code here, it should pass. So this has passed. Now, if we submit now, we're going to see something very interesting and it's going to fail. And as you can see, it has failed in this ridiculous test case, where one of the input is like 1,000,000,001. There is a reason why this is failing, and it's because we are converting these two numbers at the end, and we are trying to add the two numbers here. So what is going on is, look at this function here, get number from list. Imagine passing this argument here, this list here, into the get number from list. Then it's gonna attempt to create a JavaScript number that is like 1,000,001. But there is a problem because in JavaScript's number type, there is a maximum integer that the number can be. And that is specifically this right here. Let me zoom in real quick so that you guys can see. This is the maximum safe integer that the number type can be. And beyond this, it is no longer safe. And you're going to run into errors like the error that we are seeing here. And what they recommend is for larger integers, consider using BigInt. So BigInt is a new type that was introduced to JavaScript a couple years ago, I believe like 2 or 3 years ago. I did have a video that covers it, but that is what we should be using instead to get around this overflow here. So we will refactor our solution to use a BigInt instead. So this should no longer be returning a number, but rather it should be returning a BigInt. All in lowercase. And let's see what else we have to do. Instead of typecasting the number string as a number, let us typecast it as, not typecast, but create an instance of a BigInt like so. This is the JavaScript method. It can accept a string and it will convert that string to a BigInt. So now that we have done that, if you look, let's go back to our editor so that we have code completion. Let me copy this code and come back over here, erase this, replace it with this. If you hover over our N1 now, it is a BigInt. If you hover over our N2, it's a BigInt. And the sum of that was a BigInt. I wonder if you could see that, but we have converted that to a string. So this all still works. And this solution now should pass all of our tests. So I don't think I made any changes. So we could just submit this as is. Let us run the code first. That is passes, and let's submit this time. And it is a success. So our runtime was 107 milliseconds, which was 95.5% of TypeScript, which is pretty fast. I'm actually shocked by this because I didn't get this in my first attempt. But regardless, this is a solution. Now, let me come up with a solution that is different than this one. So let's think about the ON time complexity here. What we did here, this get number from list is O to the N, where N is the length of the list. And we are calling that twice. And then we are iterating through each of the digits and making a new list node. So it's O to the 2n is technically the time complexity of this is O to the O to the n plus m plus digits, where n is the length of L1, m is the length of L2, and d is the length of the digits, which I believe should be the addition of these. So it's either the greater of these two or the greater of these two plus 1. I believe that's how the math works. Let's see, 99 plus 99. Yeah. If you do 99 plus 99, that gives you like 100 something, so 3 digits. So it's either the max of these or the max of these plus 1. So that is our time complexity here. Let's see if we could reduce the time complexity by solving this solution in a different fashion. So let me just reset our board here. There we go. And I'm going to copy this back to my editor here. Let's erase these two functions that we have created and paste it here while keeping our list node still here so that TypeScript doesn't complain to us the fact that we are using it. All right, so how we are going to solve this one is a little bit tricky, but I think you guys can follow along. And what we are going to do is we are going to be creating our output, our singly linked list, as we iterate through each of the digits for both lists. So we're going to start with a runner that points to this 2, another runner that points to this 5, add them together and create a new list node that is 7 here. And then we're going to run to the next one, add these two and put it here. But there's a little problem, right? 4 plus 6 is 10. But we want to only add 0 here and do something with that 1 later. So what we can do is, I don't know if you guys remember from your basic arithmetic classes in like elementary school, you carry that 1 over to the next one, right? So that's what we're going to do. If our sum of our two digits is greater than 10, or greater or equal to 10, we are going to get the 1 extra and bring it over to the next number. So we're going to put 0 here and add 1 either to this 3 or to this 4. It doesn't matter. You just have to pick 1 and add 1. So let's just pretend that this has become 4. So 4 plus 4 is 8. And we are going to do that on the spot, and that should give us the output. So let us attempt to do that. And as I've said, we're going to have a runner that goes through each of the lists. So I'm just going to define them here. Let R1 is going to be L1, and let R2 is going to be L2. And I know that technically these shouldn't be null, as I said before, but whatever. We'll just keep it as it is. Not a big deal. And then we are also going to have an output here, const output, that we're going to return at the end, which is going to be a list node or null. Technically, it's not going to be null, but we're going to instantiate it as null. Do I want to do this? Actually, I don't want to do this. I do want to not start it as null, but let's have it start out as a new list node where we're going to pass in the value of it later. So I'm actually going to erase this typing here. Rid of that. And then we're going to do some magic in between line 14 and 15. And at the end, we're going to assume that the output is correctly formatted and just return the output. So the magic will come in between. And what we are going to do is this. How long should we let this while loop run, while the runner 1 and runner 2 runs? We want this to continue until, as long as R1 exists or R2 exists, we want this loop to run. And the reason why I'm doing this or is because the two lists can be of different lengths. So for example, here in this example, L1 is greater than L2. So there will come a point when R1 is running at a number that where R2 is pointing to null. So we still want to keep on running, still keep on adding the two numbers, treat these empty digits as just 0, keep on adding them together, and just return the output at the end. So let us do that right now. Let's get the sum of the digits I'm going to put that in a let variable for a reason. I'll explain. It will be clear later. We'll add up the digits, the values of the two runners right now. And that should be our digit. R1 value or R2 value. Now TypeScript is complaining to us correctly because, and there should be two type signs, R1 or R2 can be null. And that's why you can't put get dot value of null. So what we have to do is, if this exists, we're going to use optional chaining. If this exists, gives us the value, or just use 0. And we are going to do the same thing here. And for those who are not familiar with this operator, this optional chaining operator, this is essentially the same thing as R1 and R1.val. So we'll just keep it concise and do this. So that will give us the digit, but we have to consider the case where the digit is greater than 10. And for that case, and let's just think about it. What's the greatest number that this could possibly be? Let's pretend that these two were 9 and 9, right? And this was 9 and 9. So we do 9 plus 9, it's 18. We carry the 1 over. One of these becomes 10, so it's 10 and 9. 10 and 9 is 19. So the greatest that this digit can ever be is 19, meaning if we are ever in this scenario, if the digit is greater or equal to 10, then we know that the digit that we're going to carry over has to be a 1. It will never be greater than 1. So we could do something simple here. What I'm going to do is I'm going to first subtract the 10 from the digit to make the digit to be a proper digit. Let's do that right now. Digit is going to be, we're going to subtract it by 10. And we're going to do some other magic here to carry over magic here. Let's just pretend that that is done and we are outside of the if loop. Our digit, if it was greater or equal to 10, is now back to a single digit. Or if it was never a 2-digit number to begin with, we're just out here because we never entered this if condition. What do we want to do with that digit? We want to add it to this list node on the output. So the way that we are going to do that is this. Output.value is going to be the digit. And then we want our output to go to the next one, but this is where it gets tricky. Once we start reassigning what the output is pointing to, when we return it here, we're going to be pointing to the last node that we created. So we don't want to run with the output. As a matter of fact, instead, we want to have a runner of the output. So let's just call that, what should we just call it? Let's just call it runner of the output, like this. And the type of this can be list node or null. So we're never going to be doing like output equals output.next because we want to keep the reference of the original output. And instead, let's do this. Instead of saying the output.value of digit, we're going to set the runner.value is going to be the digit. And just like we have created a new list node here, if we need to create the next list node, let's do that in this first iteration before we go to the next one. And when is the scenario when we should create a new list node for the next one is if R1 exists and it has a next, or if R2 exists and it has a next. As long as one of these two has a next, then we know that we need one more additional digit. So let's just do that right now. Runner.next is going to be a new list node. And then we're going to set runner is equal to runner.next, like so. And it just auto-completed a question mark for me because it could also be null. Can it be null? Not necessarily because we have just typed it as a new list node here, but TypeScript doesn't know that. So we will let that be. And then we also have to let our R1 and R2 run, right? So let's do that. But they should only run to the next node if they are not null to begin with. So let's do that here. If R1, then set R1 is equal to R1.next, which may very well be null, but that's fine. If R2 is going to be R2.next. So we are going to keep on iterating over, adding the digits, doing some magic that carry overs the 1. Keep on doing that until we get to the end, and at the end we could return the output, who has started out as this empty list node that we have populated here. So now let us take care of this magic that is going on here. That is, if the digit that we have added together is greater or equal to 10, we have to carry over the 1. So this is going to be a bit tricky to do, and I'm going to do this. If R1 exists and its next exists, then just add it here. Add it to that one. R1, the next is val is going to be added by 1, like so. That may not be the case. Maybe for R1, we are at the, imagine this was L1. We are at the end of the line, but for L2, there is more next of values to exist. Then if R1 didn't exist, let's try for R2. Then R2.next.val gets incremented by 1. And let's put an else if here, because we only want to add 1 once. But these two now also might not be the scenario. They both might not have a next. Meaning, what if for this case, 2 plus 4, no. Let's imagine this was like 6 right here, right? 6 plus 4 is 10. We want to carry that 1 over, but neither of them have a next. So let's do this. Else if R1 exists, then we could have it have a next. Then R1.next is going to be a new list node this time because it didn't have a list node before, and we're just going to set the value to 1. Else if R2, because maybe R1 was already null and we just had to add it to R2. Then R2.next is going to be a new list node with 1. And these 4 scenarios will actually take care of all scenarios whenever we hit this, because we know that R1 or R2, at least one of them has to exist. So worst case scenario is going to hit this or it's going to hit this. It's never going to pass on all of these if statements because of this fact right here. So this should give us the correct solution. Now let us copy this and bring it over to our Leetcode. Like so, copy and paste it. Let's run the code for now to see if it passes, and it fails. And the reason why it failed is I did something incredibly stupid. You guys probably caught this, hopefully. This digit right here should have been a plus. Like so. So let me go back here. We are adding the 2 digits together, not ORing it. And that's why it gave us the first list. Because if you do something or this, it will always give you the first one, as long as that is true. So now this should work. Yep, it passes. Now let's submit. And it passes. So we got 254% milliseconds, which was actually slower than the other one. I was expecting this one to be faster. However, we ended up using more memory. This is very inconsistent, I noticed. Like before when I did this solution was much faster than my first solution. So this is not 100% reliable, I don't think. But either way, those were the 2 different ways that we could solve this add 2 numbers problem. So hope you guys like this. If you guys like this content, please like this video to let me know that you want more of it. And when the time comes, I will be submitting a part 3 of this Leetcode a day keeps the dentist away. So please stay subscribed. Subscribe to my video. Subscribe to my channel, I mean. And I will see you guys next time.